Hello, welcome to Stars, Cells, and God. We're here to discuss discoveries taking place at the frontiers of science, discoveries that have theological and philosophical implications, as well as discoveries that point to the reality of God's existence. I'm Jeff Zwerig, joined with Dr. Eric Hadeen. But before we get into the topics of discussion, I wanted to encourage you to subscribe to our channel, Reasons to Believe, and click on the bell icon so you can be informed of our new videos. Learn more at reasons.org or by following us on social media at RTB_official. Eric, good to have you here today.
Thank you so much, Jeff.
I know you've been here on a past show. I wonder, you might just kind of give a little bit of background of who you are so that we know just a little bit about you before we get into the discussion today.
All right. Well, my background is as a physicist. I've done research in experimental plasma physics and integrated optics, and then I taught physics at a couple of different universities, Taylor University in Indiana, Ball State University for 15 years in Indiana. And there I did, again, research, but in a different field of computational nanoelectronics.
Oh, wow.
And then I finished kind of my academic career with a short time at Biola University here in Southern California.
Oh, very good. You had pretty decent spectrum of where you're doing there. So,
Yes.
well, again, I'm excited about having you on the show. I know we're going to be talking about information and living systems and non-living systems. So, I'm just going to turn the floor over to you and kind of lead us through our discussion this morning.
Okay, so I appreciate the opportunity to share about this because I believe that this topic really is particularly relevant and important for the discussion of, is there evidence for God as a creator within this natural universe? And so the topic of information theory can get fairly technical and mathematical, and I'm going to try to just keep it more general today and conceptual. But thinking about living systems, we know that they are particularly described by high levels of what we might call specified complexity. And that's necessary for them to actually function at the cellular level. And so what we can do then is ask, can natural processes, things that are governed by the laws of physics, I'm a physicist and I know what the laws of nature are and what's available from nature's side, can nature then be expected to generate the molecular complexity that's found within all living systems? And so as we go forward here in our discussion, I hope to provide some rationale that would suggest that no, nature is not able to actually accomplish what we see within every living system, even the very simplest single-celled organisms.
All right, so why don't we get into that? I know you mentioned just a second ago specified complexity, that's the sort of thing that give us a little primer on what that is, just so that we know what we're talking about as we go through our discussion
Yes,
today.
and I think it's important for us to understand that when we talk about the complexity found within living systems, it's different than what might be called an ordered system. In fact, nature can produce ordered systems. It's very good at that. And that would be any sort of kind of like a crystalline structure, for example, might even be as a snowflake. And it's simply taking on the typical structure based on the way the water molecules in the solid state form bonds with each other. And it then produces the typical six-sided snowflake pattern. It really just follows the laws of physics. But living systems are not ordered in that way. And then kind of an opposite effect that nature is also good at. We'll kind of get rid of the things that nature can do first and then talk about what it can't do. But the opposite to the ordered system is a random but complex system that might be typified by just a cloud. And, a cloud is also water droplets, but the position of the droplets is completely random, and there's no particular structure to it. And if you were to try to, say, come up with a spreadsheet that gave the position, the velocity, direction and magnitude of each water molecule in the cloud, it would be completely difficult. It would be
Mhm.
so complex. But the thing is, ordered systems and these random complex systems both fail to describe what we have in life. Um, Living systems are complex but not random,
Hmm.
and living systems are not ordered like a snowflake. They're complex but specific. And just to give an example from a different kind of a setting than living systems, something people can relate to. Think of the letters that make up the words in a book. And if you just looked at the arrangement of the letters, there's not a repetitious pattern to those. It's not
Mhm.
like you've got A, B, C, D repeated 1,000 times and that makes up the story.
Right.
Um, there would be no information in that. But neither are the sequence of letters randomized, which would, the
Mhm.
random arrangement of letters would be like the cloud, the repetitious A, B, C, D, A, B, C, D, that would be like the snowflake. So, what is it? Well, there's a complexity. If you look at the letters in let's say, the first page of a book, you will not find any pattern that suggests a repetition or order. But what you will find is a complex, meaningful message that's based on the arrangement of the letters, and it can only be defined as something that is produced by an intelligent mind. There's no aspect of nature, no law of gravity or electromagnetic interaction or any principle of nature that can produce that kind of complex but specific ordering. So the specific ordering of the letters
Mhm.
is, of course, something that we recognize as humans as a meaningful arrangement corresponding to the language that we know.
It's interesting. I was just sitting there thinking about, okay, so what, if you were to analyze the letters on a page, I'm sure, you'll sit there and you'll find that there are certain letters that have a greater frequency than other letters. You're going to find
Sure.
more E's and T's and S's than you will X's, E's, and Q's.
Yes.
Um, you're right. There's no repetition because that almost makes it devoid of information, if you will.
Yeah, that's a good point.
Whereas if it's just random, either one of those kind of remove the information. But it seems almost intrinsically to talk about information in the letters, there's got to be something that processes the information, if you will.
Yes, yes. And it has to be an intelligent mind, and a mind that even can, to properly interpret the information there, it has to be a mind that is familiar with the language.
Hmm.
Like if you had letters, but it was in a language that is unfamiliar to you or me, then we might believe that there's meaningful information there, but we wouldn't be able to interpret it easily.
Okay.
Now, there are specialists in fields like cryptography that deal with just that problem
Right.
of seeing what looks like maybe a meaningful sequence of symbols, but it's unfamiliar. But there are ways to actually sort out what the message is and to kind
Right.
of break the code. Um, Now, yeah, I think that if we go back to the question of how can we maybe decide whether or not natural forces can produce this complex specified pattern, not to write a book,
Hmm.
but to produce the biomolecular machinery that makes up a single cell.
Hmm.
And again, it's not ordered, it's not random, it's arranged in a specific way that allows for the functioning of the cell. The cell is filled with molecular machines. It's like a metropolis,
Hmm.
and it's so much more than just something that is like a blob of jello surrounded by a membrane, the
Hmm.
interior of the cell. So why can't nature do that? And one thing that I always like to say is that anytime you try to put together something that's complex, functional, specific, and meaningful, there are always more ways to go wrong than to go right.
Yes.
If you just had a pile of uh, amino acids, keeping it within the context of biochemistry here. Just if you have a pile of amino acids, let's say even the ones that are always found within living systems, and you wanted to build a protein, which is essentially made up of a long string of amino acids bonded together, you would imagine nature just putting them together by selecting them randomly.
Hmm.
Well, how many ways are there to go right, meaning to end up with a functional protein in the end,
Hmm.
versus going wrong, where you don't get a functional protein? And this has been actually studied by biochemists, and the answer is that even for just a moderate protein, it's about one chance out of 10 to the 77th in terms
Hmm.
of there's maybe one chance of getting it all correct, the correct sequence that produces the functional protein, versus how many ways to go wrong. 10
Right.
to the 77th, that's almost, that's a huge number, almost as large as the total number of particles in the universe.
Right.
And so there's just no way to appeal to luck at this point, which I know sometimes people who don't want to allow God into the discussion might say, well, okay, so it's improbable, but improbable things happen now and then. And and this, arrangement of amino acids that led to functional proteins, that was just one of those lucky things that came about. But it's beyond what we can expect nature to produce by any sort of a coincidental arrangement.
No, that's I appreciate that, and that's honestly one of the things that just kind of struck me as I got into apologetics was just recognizing the improbability of a lot of things. I do know as a physicist, and I'm sure you deal with this as well. When you run into this, it's like, okay, this is what our understanding of physics says, and this is what we see working. And when there's this huge gap, you see numbers like 10 to the 20, 10 to the 70 or something like that. Generally, that's a sign that we're missing something. So if we're just saying, all right, these all just kind of go together randomly, we've got a problem. Might there be some sort of physical mechanism that's driving the assembly in a way that results in some more useful information? Like I know the snowflake is not a great example because it's ordered, but that's not random, if you will, because snowflakes couldn't just have any configuration. The physics kind
Right,
of dictates what can happen, if you will. Might the
right.
chemistry be dictating what could happen?
Well, that's a reasonable thought, in terms of trying to understand if there might be a naturalistic explanation. But let's just run with that and suppose that the chemical bonds that we'll just start with amino acids. Say we've got all of those, because nature can produce amino acids on its own, and the reason is that they're just not that complex. They're not composed of that many atoms, maybe 20, 25 atoms, something like that. Um, so let's start with those. And then let's imagine that nature had a preference for bonding certain amino acids together, a
Hmm.
preference that kind of, in a way, naturally selected which amino acids would bond next in the sequence of amino acids that makes up the protein.
Hmm.
And so if that were the case, then that's what would happen. And that's all that would happen.
Okay.
You would get an extremely limited outcome if there was a natural law that dictated that this outcome is going to happen. Now, there's not just one protein in living systems.
Right.
It's estimated that within the human body, there may be as many as 80,000 different proteins. Some people estimate a little more, a little less, but
Right.
not just 80,000 proteins, but that tens of thousands of different proteins that have different functions.
Hmm.
And if nature had a preference for putting amino acids together that built just one type of protein, that's all we would have. And of course, with one type of protein, you wouldn't have life.
Hmm.
It takes far more than that. And so you cannot say that nature selects based on, say, molecular attractions, trying to put together the correct amino acids to
Hmm.
reach a lower energy state. And because if you did, that's what you'd get, and that's all that you would get. It would be
Right.
like
No.
having one paragraph, and that's the only paragraph that's ever written.
Hmm.
And of course, that's nothing compared to the, say, information within a whole library of books.
Hmm.
And living systems are more like a library of books rather than just one
Yeah.
paragraph.
No, and I think my thinking there, and I was just kind of brainstorming how would I think about that is, okay, yes, you've got this long string that goes, to get the correct protein, you need to have the amino acids lined up in a certain sequence.
Mhm.
The reality of these are fairly complex chemical molecules. I mean, the
Mhm.
amino acids are relatively simple, but the more you put together, they become more complex.
Yeah.
That complexity now begins to interact with the environment. And so you have now this coupling between, okay, no, there isn't a certain chemical bonding that only this sort of chain is formed, but now these sorts of chains, they fold and they behave different ways. And so that interaction with the environment now gives more flexibility or more diversity of what could come. And so in that sense, there are certain things that play around in the environment longer, or these sorts of structures stick around, and might those structures that stick around correspond to what life requires?
Well, yeah. Now, so again, let's take that consideration or option. Again, giving nature the benefit of the doubt as to maybe being able to move forward towards building what's necessary for life. And so, if a given protein or sequence of amino acids is interacting with the environment, you're back to relying on luck.
Okay.
Um, because anytime you have a system, just to generally describe something, that is allowed to naturally interact with its surroundings, its environment, you always lose information. This is actually a good kind of a segue. It's a big way to describe the laws of physics that describe what information and natural processes do.
Hmm.
And natural processes always destroy information with the passage of time. And this is a result that's actually based in physics. It's not the simple second law of thermodynamics,
It
which
seems related to that.
it
I'm
is.
glad
It
you.
is certainly related to that, but it is more of a general version of it, you might say, that is based in the principles of quantum mechanics and
Hmm.
statistical physics. And so, if you think of in quantum mechanics, this diverge a little bit
All right.
into some physics here, but in quantum mechanics, any system can be described by its wave function. And that's a quantum mechanical phenomenon. It's possible to typically write it down as a mathematical expression, this wave function. But the important thing about a wave function, even if it's a wave function of just a single particle or a molecule or something more complex, is that the wave function contains all the information that
Hmm.
it's possible for an observer to know about the system.
Okay.
And what happens is that unless that system is 100% isolated from its surroundings,
Hmm.
natural interactions between the system and the surroundings will lead to an uncontrollable and irreversible loss of information from the system into the environment. And
Hmm.
in quantum mechanics, in the field of, say, quantum computing. Those who are trying to develop quantum computers are always struggling against this process, and it's called decoherence.
Right.
The wave function begins to kind of mix and spread into the environment, and that leads to a loss of information.
So
And
it sounds almost kind of like, similar to a thermalization process. You can have a
yes.
hot body
Mhm.
that remains hot, but the moment it starts to connect to the environment is always going to be cooler, and the information or the heat is going to flow to the environment, not the other way around. It
Yes.
sounds akin to that.
Exactly, and I'm sure you know that you're describing the classical second law of thermodynamics by what you just said.
Right.
This sort of just the normal process that a cup of hot coffee on the table loses heat to the surrounding air, and it never goes the other way around. And that's
Or it's so incredibly rare that we just don't worry about it.
well, incredibly rare, but it won't happen.
Exactly, right,
It
yeah.
it just it's not even that we can open up a window for a very rare event that a cup of cold water on the table will begin to boil because the heat from the environment is suddenly and really in an unusual way being directed into it. That doesn't violate the first law of thermodynamics having to do with energy transfer,
Yeah.
but it completely violates the second law of thermodynamics, and it will never happen.
No, and that's I guess that's part of the as a physicist I know incredibly rare means like 1 part in 10 to the who knows what number. It's this incredibly large number that I can't say it's zero, but for all intents and purposes, it just never happens.
Well,
Yeah,
and
so
I like to actually claim that it's zero, and
you would? Okay.
the reason is that we do not live in an infinite universe where we have infinite possibilities.
Okay.
We actually, I mean, the reality is that we live in a finite space-time environment, meaning there's only so much time, there's
Mhm.
only so many seconds that have transpired since the beginning of this universe, and the size of this universe out to the cosmic horizon is only so many light years.
Right.
There's just not an infinite space, and there's not an infinite amount of time. And so when the probabilities are smaller than what has been termed the probabilistic resources
Mhm.
of the universe, then we can legitimately claim that it has a zero chance of happening in this universe.
Okay, so that's kind of the idea. Yes, you can calculate a probability, and let's say there's 10 to the 100 option or 10 to the 100 samples that you could do. If your
Mhm.
probability is smaller than 10 to 100, you can effectively say it's not going to happen because there isn't enough sample size to make that a reasonable option. Is that effectively
Yes,
what you're
and
saying?
actually, I think the absolute limit is I don't remember the exact number, but I believe it's closer to 10 to 140th. But
Great.
anything that's less probable than that is just off the table, and you can legitimately claim that it has a zero chance of happening in this universe. It's maybe if you had
Mhm.
an infinite universe that had existed for an infinite amount of time, there would be it would be possible to have more unlikely events happening, but we've got limits
Yeah,
here.
no, so okay, so we're in the confines of our universe. Yes, we could talk about fine tuning in terms of what all needed to happen, but given that there's only so many protons, so much space, so much time,
Mhm.
there's a limit to how many things could happen. And what we're talking about here is beyond that probability. So effectively, we say natural processes can't do that
Right,
in our universe.
right. The probability of obtaining even a single cell, just the simplest type of organism,
Mhm.
is such a low probability that were you to somehow gather all of the probabilistic resources of the universe and focus it on trying to make that single cell, you wouldn't even come close
Mhm.
to allowing it to happen by natural processes. So what I might want to shift to is to ask, well, then, how can complex, meaningful, functional things happen?
Mhm.
And we don't even need to limit the discussion to the origin of life, which is nothing that any of us can bring about. Even the most advanced bio research labs cannot bring about the origin of life, even as they try to do it with teams
Mhm.
of scientists. But we
Right.
can make things as complicated as a laptop computer.
Mhm.
And how did that happen? Well, humans used not just luck, and they didn't just put the raw ingredients of a laptop in a room and kind of allow natural processes to assemble. There was a intelligence involved
Mhm.
in making choices as to what pieces were put together in what way in order to bring about, of
Right.
course, the desired outcome.
Mhm.
So how does how do we get away with that where natural processes couldn't? Like I don't think I've ever met anybody that believes that nature could produce a laptop computer that functions on its own without.
Right.
And so what's the difference? And of course I believe that it's our our minds.
Mhm.
Now, sort of see if we can follow with me here the argument. If the materialist viewpoint is true, by that I mean someone who believes there's nothing in the universe except matter and energy and basically the laws of physics.
Mhm.
And they might believe that unguided processes through evolution led to the arrival of humans on the scene. And then humans are now somehow, by more evolutionary processes, intelligent, and so now we're making
Mhm.
laptops and everything else in our technological society. So that person is faced with basically forced to believe that this universe, given enough time, will produce laptop computers,
Mhm.
kind of by means of the intermediate step of producing humans.
Oh, okay, yeah. So because it produced humans that can produce laptops, effectively we're an accident or a lucky chance. The fact that we are the lucky chance that can produce laptops, this actually means the universe is producing laptops by chance.
Right. So if you kind of fly back in time to sometime after the Big Bang, but before planets had even formed, you've
Mhm.
got a universe just filled with simple uh, ions of hydrogen and helium, and eventually you get atoms of those.
Mhm.
And so again, a materialist would have to believe that that universe, which is our universe a long
Mhm.
time ago, in just a few billion years, will be producing laptops and
Mhm.
microwave ovens and cell phones and automobiles and metropolises
Mhm.
and Lego dragons, you know,
Right.
on its own. And we can just look at the beginning, random atoms, shortly after the Big Bang, and what we have now, everything I've just described. And the materialist has to really come forth and say, yeah, the laws of physics inevitably brought about all of this modern
Mhm.
technology. And yet, as a physicist, I would have to say that just doesn't sound believable.
Right.
And there
Well,
are reasons for that.
yeah, let me ask you a question because there's we have these information systems, complex molecules inside life. And using natural processes, we can figure out how they work. We can figure out why they replicate. I mean, there's not. It's not like we have this complete understanding of life, but it doesn't
Mhm.
seem like there's anything unphysical going on there.
No, that's right.
So there's part of me that's a very sympathetic to. It's like we see physically that life just happens physically. Why would we expect it to be something other than the physics that causes life in the first place?
Well, and I agree with you 100% that within any sort of a living organism, that I don't believe that there's violations of the laws of physics going on at our cellular level that is responsible for us being physically alive. I agree with what you said that the laws of physics are fully being satisfied, including laws of thermodynamics and so
Right.
on, in the activities within our cells, the metabolism and the energy harvesting and all of that. But the real question is, how did the mechanism get there in the first place? And you say, well, we were all born, right? Well, so in biology, if you look at science, science reaches conclusions based on observations of
Mhm.
nature. You drop a rock enough times, you begin to understand, okay, there's something like the law of gravity. So you observe nature and see how it works. You can have charged particles and observe either attractions or repulsions, and you begin to measure the effect and come up with Coulomb's law for describing the force of those interactions
Right.
based on observation. So what do we observe with regard to living systems and the very origin of living systems? Well, the only thing we've ever observed is that every cell always comes from a pre-existing cell.
Okay.
And that's kind of a maxim it's a law within biology.
Mhm.
There's never been any observation any different. And so I think that it's valid to suggest that, well, that's what's required, is a pre-existing cell. So there's nothing within our observations of nature that suggests that there even should be a way to go from non-living things to living things, because we've never observed that. And as scientists, the conclusions of science are based on what we observe. And
Okay.
no one has ever observed that. So anybody that suggests that life can arise from non-life is not basing their conclusion upon science, which is based on observations of nature, but
Okay.
they're basing their conclusion upon some presupposition, some worldview, or some maybe even quasi-religious belief. They're certainly not basing it upon a scientific conclusion.
That's an interesting point. And, I'm curious your thoughts. I'll throw out an idea here is that there's often this idea that, okay, we'll stick with the origin of life here, that, okay, we, as scientists, we only have natural processes. And so we have to stick within natural processes. I agree that that is by far the best way to determine what happens, because that's the history has shown as we've looked for natural processes, we found explanations for
Sure,
things.
yeah.
As we're looking at that, what you're saying is that cells come from cells. And so now we're going back and asking the question, how did the first cell come? We don't have any science or observation of that, if you will.
Mhm.
All the data seems to point to there needing to be previous cells. So now we've got a worldview or a philosophical assertion that we're making. Either this came just from physical processes, this came because God created it, whatever. Those are all not scientific statements, they're philosophical assertions
Right.
that are not the science, but now we can investigate if that assertion is correct, what scientific consequences would it have.
Yes.
So it's not like the philosophies, in some sense, we're kind of, by saying it's all physics or all materialism, we're smuggling a worldview into the science. And we're missing that the whole point is, how do we test the science of, or the scientific consequences of the philosophical
Right. In a way, how do
statement?
we sort out which worldview is correct? And you mentioned
Yeah.
either a naturalistic processes that led to the first cell, or perhaps God created it.
Mhm.
And is there any way in which we can sort that out besides just having an argument? And that never really leads to good conclusions. But I believe that there is. And again, as a physicist, I would say that understanding how nature works can allow us to draw conclusions of what nature can do. So
Yeah.
here the question is, can nature produce cells? And so we need to understand how nature works.
Hmm.
And as we've already talked about, in in nature, there is a general tendency for um, randomization,
Hmm.
for things to mix, and information, which is i- it's possible to ascribe a high value of information to the particular specific complex structures within a cell.
Hmm.
And as we know, information, it might be an immaterial thing, um, but it's always expressed in one way or another within physical arrangements, like the letters on a page,
Right. Yeah.
or a biochemist would recognize information in the sequence of nucleotides within a DNA
Hmm.
molecule.
Right.
So those are physical things that give us meaningful information. But physical things always obey the laws of physics. And the laws of nature, as we've already talked about, um, will guarantee that on average, things will mix over time.
Hmm.
Um, and complex things will lose information over
Right.
time. Um, and this is just unavoidable. It never goes the other way around, and the fundamental basis for it is that there's always more ways to go wrong
Hmm.
than to go right. And so, for me, that is particularly relevant for answering this question of which worldview is the correct one for determining this answer to a question that nobody has actually seen uh, non-living materials rearrange themselves into a cell.
Hmm.
But we obviously have cells, and it was obvious that at some point in the universe there were no cells. So somehow it happened, and it's either nature or it's God.
Yeah.
But I think that this discussion of what nature does to information and complex systems, namely it degrades information, it tends to break down complexity, because there's more ways to break down a complex system than there are to enhance it.
Hmm.
And so let's say you're only halfway there towards the functioning of a cell. Well, to complete the process, to get from halfway, like a half built cell, to a fully
Hmm.
functional cell, you would have to do many other kind of adjustments that are specific, that are the right choice, the right step.
Right.
And compared to how you could go right with increasing the complexity towards a fully functioning cell, there are so many more ways to go wrong.
Hmm.
And because it's not a single step, but a multi step sequence to arrive at the end goal, um, anytime if you suggest that it just is one lucky step after another, any that's showing that the game is rigged somehow.
Gotcha. Yeah.
And that would that's just we already know that that's not going to happen. We have studied nature. We know that it degrades complex systems with time, and so that's the way it's going to work. And it kind of rules out any naturalistic origin of life.
So I'm gonna throw one question that a friendly colleague posed to me that I'm curious how you would respond, and then I'll let you wrap up or throw in a final couple of comments before I wrap up. So, as you mentioned, we have cells now, and there was some point in time in the universe where there wasn't cells.
Hmm.
So if I would say God, because I think God did it. If God says, okay, let's go look and see, let's go look at what happened when life started.
Okay.
What do you think we would find there? Would we find just boom, it's there? Would we find natural processes at work? Would we find what do you think that would look like?
Well, that's a deep question. um, kind of. Maybe we could frame it this way: how does it look when God intervenes in nature?
Hmm.
In this case, particularly in creating the first life. Um, and I don't think that it would look anything different than what we might expect if we did it ourselves.
Okay.
There would be a movement of raw materials together and being connected in the completely correct, complex, specified manner that results in functional cells and then
Hmm.
eventually a whole multicellular organism and a being
Hmm.
like Adam.
Okay.
Um, and so it would look like a miracle. How long did it take? I don't know. I mean, God could have done it in an instant, or He may have taken an hour. I have no idea, and that's
Right.
that's kind of an irrelevant question in my mind, but it's fascinating to think about.
Right.
Um, but here's the thing: in general, even kind of taking it back to what we discussed earlier, how do we as humans make something like a laptop computer, or how do we write a story, or how do we put together a jigsaw puzzle? Well, we use our mind. And why does that succeed when natural processes could
Hmm.
not succeed?
Right.
And I would have to say that the fact that it does succeed, that we can succeed at producing complex machinery and so on, is proof that our minds are actually immaterial.
Hmm.
Our minds are not just a bunch of atoms in a complex arrangement working purely by the laws of physics. They're not just interacting according to electromagnetic forces and so on.
So
But
they are doing that, and
they
that
are
they're
doing that.
interacting by electromagnetic forces. That's just not all that's going on
That's
there.
not all that's going on. I believe that our minds are actually, if you want to say it this way, the neurons in our brains are actually affected by the immaterial
Hmm.
mind, the
Okay.
spirit of our beings. And so why can that succeed? And it's because the immaterial aspect of our mind is not dependent upon the kind of the guaranteed outcomes of the laws of physics,
Hmm.
which are that things will mix and randomization will take place and information loss will occur. Uh, our minds aren't affected by that. So we can,
Or
with our,
they're not determined by that.
right, they're
Yeah.
not determined. And so we can, with our minds, imagine an outcome. Like we can imagine how a puzzle should look. And we can then cause our body to take the pieces and put them together in this particular arrangement that completes the puzzle.
Right.
Um, Whereas just shaking the puzzle box and expecting, the 1,000-piece puzzle to come together, that's one of those things that will just never happen in the
Hmm.
time frame limitations of our universe. So the fact that we can do it and that we have done it, not only made puzzles, but all these other aspects of our technological society, is actually proof that our minds have some aspect to them that is beyond the physical.
Hmm.
And so I would agree that God, of course, is in the same category, having an immaterial aspect that He
Hmm.
can then affect and override, if you will, the natural processes of atoms and bring together all those atoms in a way that results in a living being.
Very good. Any final comments before we close?
Well, just thank you for the opportunity to talk about these really fascinating and important topics, because to me it's important because our origin is tied to our significance.
Hmm.
And having our origin be intentional and designed on purpose by a loving God gives us significance that goes far beyond anything that we could hope to latch onto if we were just random outcomes of the forces of nature.
Well, very, very good. I appreciate your
Thank
time
you.
here, Eric. And
Thank you.
thank you for joining us today. I want to encourage you to join our discussion in the comments below. Remember to like this video, to subscribe for more content. We release new episodes of Stars, Cells, and God each Wednesday. They're available here on YouTube and on your favorite podcast app. Be sure to share this video with a friend. And remember, the more we know about science, the more reasons we have to believe.